Welcome to the first of a three-part webinar series on the shifts for the Connecticut Core Standards for Math. Before we get into the first shift of focus, we need to take a look into the standards. The Connecticut Core Standards include both the content standards and the practice standards. The standards for mathematical content are very specific about concepts, procedures, and skills that are to be learned at each grade level. These standards are arranged into clusters or groups of related standards, and the clusters themselves are grouped into domains. The standards for mathematical practice do not change from kindergarten to high school. These standards describe behaviors such as reasoning, communication, making arguments, and modeling that demonstrate students are mathematically proficient. The standards for mathematical practice should not be taught in isolation, but rather embedded in every lesson. This is not to say that students should be engaging in all of the practices at all times in a math classroom. Rather, they should be used strategically in the design of the lessons and problems. Taking a closer look at the organization of the standards for mathematical practice, it can be seen that there are two overarching practices. The remaining 6 practice standards are grouped into the categories of reasoning and explaining, modeling, and using tools and seeing structure in generalizing. The standards for math practice and the standards for math content lead to the 3 instructional shifts required by the Connecticut Core Standards. These shifts of focus, coherence, and rigor help frame the way for changes in curriculum, instructional practice, and assessment to achieve alignment with the standards. The remaining part of this webinar will dive into the first shift of focus. There needs to be a focus on the standards. This means that math educators will teach less but with more understanding. Many math teachers can relate to a mile-wide, inch-deep curriculum where instruction feels rushed. The Connecticut Core Standards require that the curriculum significantly narrow the scope of content to allow time to go more deeply into content. The concept is to focus deeply on what is emphasized in the standards so that students gain strong foundations. The need for this shift is evidenced in the Trends in International Math and Science study. This study showed that the curriculum in the United States covers far more topics than those in countries that significantly outperform us. As you can visually see, the overall shape of math topics in A+ countries and those typical in the United States pre-Common Core is different. In 2/3 of the high-performing countries, the foundations are laid and then further knowledge is built on them. The design principle is focus and coherence progression. On the contrary, in the U.S., the design principle is to teach everything every year and hope it sticks. It is easy to see the uniqueness of each grade level as opposed to the nearly identical grade levels in the United States. These two tables provide another way to look at this. The top table shows the traditional domain organization of mathematical standards. All 5 domains were equally important in all grades K-8. The bottom table shows the reorganization under the Common Core State Standards. The color coding shows how the domain of number has been split up into multiple domains within K-5 in order to emphasize the importance of this work in the elementary grades. The green shading shows that algebra has been turned into the major focus of the middle school grades. Everything is no longer created equal. Instead, the standards are designed for deep understanding of core concepts by which to build upon for future learning. There are 2 levels of focus that need to be addressed to comprehend this shift. The first level of focus is knowing what is to be taught at each grade level. Knowing what to focus on at each grade level is based upon the critical areas identified at each grade level or course. These critical areas outline the essential mathematical ideas that will create the foundation for the mathematical learning in subsequent years that lead to ensuring students are college and career ready. In order to assess your level of understanding the focus at each grade level, please pause this webinar and access the Focus Activity Number 1 sheet in the Supporting Documents section and complete. Welcome back. This slide provides the answers to the activity just completed. While all of the topics at each level are part of the standards, they are not all a focus. Let's take a closer look at the organization of the standards and how the focus of the critical areas are presented at the K-8 level. In these grades, there are about 2 to 4 identified critical areas. In this grade 3 example, you can see that there are 4 critical areas specified. Besides just naming the critical areas, each grade level provides a more detailed description of each critical area so that there is clear understanding of the expectations. The concept of critical areas shifts from grade-specific to course-specific at the high school level. Each course outlined in the Pathways document of the Common Core State Standards is organized around critical areas, which at the high school level are called units. The descriptions of the critical area for high school clearly articulate how the unit is building upon prior learning. The grade and course introductions that contain the critical area information can be found by accessing Focus Activity Number 2. Please pause this webinar, look for your grade or course document, and as you read it, think about these questions. The intent of this activity was to help you gain a better understanding of the focus at each grade level or course you teach. This can also help as you pace out or revise your curriculum. Those of you that teach at the K-5 level should have noticed that number sense is most important. This graph illustrates how specific focus on building number sense in the early years prepares students for algebra when they get to high school. In making the shift to focus, it is important to be aware of topics that tend to crowd out focus, especially at the elementary level. These topics take away from the time needed to build a deep understanding of number sense in the lower grades. They are also often the topics that get repeated in each grade. This slide shows not only the most common offenders, but also the grades in which they are first introduced in the Connecticut Core Standards for Math. A second level of focus is knowing the major work of each grade. This is understanding the connection between the critical areas and the standards. The second level of focus helps in instructional planning to ensure that appropriate time is spent on specific clusters. In order to effectively address this level of focus, educators must examine each critical area and identify the skills and understandings within that critical area. Let's look at an example from grade 3. In grade 3, one critical area is students develop an understanding of the meanings of multiplication and division and strategies for multiplication and division within 100. Looking at the description of this critical area, one specific skill that can be identified is using properties of operations to calculate products of whole numbers. Once the specific skills are known, the domains and clusters in which these skills would most likely be found need to be ascertained. As can be seen from our example, the skill we identified would most likely be found in the operations and algebraic thinking domain. More specifically, in the clusters of represent and solve problems involving multiplication and division, understand properties of multiplication and the relationship between multiplication and division, and multiply and divide within 100. Continuing on with this example, the standards within the clusters need to be closely examined to identify the standards that match the skill or understanding. This slide shows an example of the specific standards within the operations and algebraic thinking domain that speak to the skill noted earlier. As you can imagine, this would take a great deal of time to do for all of the grade levels and all of the skills within the critical areas. Thankfully, this work has already been done for us by Student Achievement Partners. Student Achievement Partners has created focus by grade level documents that examine the clusters at each grade level, K-8, and identifies them either major, supporting, or additional. Supporting and additional clusters are not nice-to-know concepts. All of the standards are important, but these emphasis labels help a teacher know what is most important, which ideas support a deep conceptual understanding of the most important ideas, and which are setting the groundwork for future math concepts. While these documents are only for K-8, there is also guidance around which conceptual categories, clusters, and standards should account for the majority of the coursework at the high school level. This table from the high school publishers criteria for the Common Core State Standards for Mathematics identifies a subset of material that students must study to be college and career ready. As previously stated, all of the standards must be taught. However, when planning for instruction, it is important to keep in mind that a large majority of the time should be spent on the standards within the major clusters or widely applicable prerequisites. What then constitutes a large majority of the time? According to the publisher's criteria, large majority of the time is anywhere from 65% to 85% of yearly instructional time. And in lower elementary grades, it should be more towards the 85%. The language of the standards assists in ensuring that the majority of the time is spent on the major work of the grade. In this third grade standard, a cluster in the measurement and data domain that is considered supporting work, bar charts do not become another thing to cover. Rather, bar charts are linked to the major work of grade 3. To further demonstrate this point, let's look at 2 grade 4 standards. Measurement and data is not major work for grade 4. However, operations and algebraic thinking is. This example demonstrates how a standard from major work can be embedded within questions related to supporting or additional work. Now that you have an understanding of what we mean by major work of the grade relative to focus, it is time for you to take a deeper look into your grade level or course. In focus activity number 3, you will find the focus by grade level documents for grades K-8 and the widely applicable prerequisites for high school. Please pause this webinar, locate the appropriate documents for your assignment, and read it over. As you do this, think about these questions, which are intended to help you determine ways to improve your practice to better address the shift of focus in your classroom. In summary of this webinar on focus, these next 2 slides show the focus areas for each grade K-8 and conceptual categories at the high school. On this K-8 slide, the progression of topics that lead from a foundation of number sense to an understanding of algebra is evident. At the high school level, there are a variety of ways to design courses. Therefore, this slide shows which clusters should be the focus within each conceptual category. It is important that courses that teach the conceptual categories focus on these clusters appropriately. Thank you for viewing the first of the 3-part webinar series on focus. The second part will be dedicated to exploring the shift of coherence. If you have any remaining questions, please feel free to contact me. Have a good day.